We're going to start off with a quiz as usual. And the quiz is sketch graphs of three linear functions. F of x with intercepts 0, 4, and 5, 0. And g of x with given intercepts and h of x equal to 2. Okay? And I recommended starting out with this much of a grid. X-axis, y-axis, align it for x equals 10, align for y equals 10. Once you do that, it's easy to locate 0, 4, and 5, 0. 0, 4 is on the y-axis, a little less than half as high as 10, so I'll just say 0, 4 is maybe there. And 5, 0 is halfway between the y-axis and x equals 10 on the x-axis. There it is. So we can sketch this line. Okay, and we can say, okay, that's a y equals f of x line. G of x, well, we go out the same way. Intercept 0, negative 4, so it's far below, the y-intercept is as far below the x-axis as the 0, 4 intercept of f of x is above it. And then 2, 0. Well, here's x equals 0, here's x equals 5, here's x equals 2, let's say. So there's 2, 0. And we get a line. And then h of x equals 2. Well, that's just a constant value. H of x equals 2 means y equals 2. So here's y equals, and we just drew y equals g of x. Let's label that. And then h of x equals 2. I'm going to say, okay, let's see, y equals 2 is about here. Y equals h of x, which equals 2. We don't have the formulas for f of x and g of x, but it would be easy to get them. We've got 2 points. It's easy to get the formula. Okay? And of course, we got to know how to do that. All right, now I want to construct a couple more lines. First of all, I want to go ahead and extend this g of x line all the way up to where y equals 10. So that all these lines, except for the horizontal line, hit the x equals 10 line and the y equals 10 line. Now, let's shade the f of x line on the interval from -3 to 1. Let's just do that, okay? Can you shade the f of x line? It just means like make it bolder. And take the graph you got and just kind of, if this is your line, just make it a little darker on that interval. Okay, that was very well done. Let's shade f of x from -3 to 1 just to confirm what people have done. Okay, so I'm just going to say, okay, here's the x equals 3 line. Now, when x equals -3, we have a closed bracket. So the point on the f of x graph where x equals -3 is included. So we're going to make a closed dot there. Then x equals 1 is about here. The open parenthesis on the 1 tells me that we're not going to include that point. So there is the f of x part of the graph. The g of x part starts at x equals 2, which, I drew my x equals 1 point a little too far to the right. Doesn't make any sense that x equals 2 should be here. X equals 1 should be about here. But let's just pretend we've done this more accurately. Okay, so from x equals 2 to x equals 5, okay, well, x equals 5 here. We have closed brackets at both ends. So we're going to include the x equals 2 point in the x equals 5 point, and there we have it. And then finally, we're going to trace over h of x on the interval from 5 to 10. Now, that interval is obvious. I'm going to go from here to here. I use open circles because both of these are open. And now the blue, orange, and green graphs make up the graph of the function k of x equals the f of x function from -3 to 1 from x equals 2 to x equals 5, and the h of x function from x going from 5 to 10. Now I could write the formulas for these functions. You could figure out the formulas and fill in the values. H of x would just be 2. Okay. F of x would have a slope of -4/5 with a y-intercept of 4, so it'd be f of x equals 4 minus 4/5 x. Okay. I'm not going to do that, but that would be easily done. Okay. So that's the idea of piecewise functions. I can also, especially draw my functions light, I can then go ahead and erase the parts that we haven't used. And I never did fill in the line for the h of x function, which would be here. And now we see 3 segments of the graph. We also notice that there's nothing on the graph between x equals 1 and x equals 2. So that the domain is -3, 1 union with 2, 10 with open endpoints, open right endpoints in each of those intervals. I'm not sure why this is difficult for people, but I know that the one thing my grandson ran into in his pre-calculus course and had to ask me a question about was this. I mean, a kid was in the top third of his class in power systems engineering at Virginia Tech. Smart kid, but this threw him, and it almost always throws almost every student. Okay. But it's a pretty simple idea. So ponder it. Okay, looking at absolute value functions. Take for an example, f of x equals absolute value of x minus 2. I make a table. Let's just use x values. Two through 4. Can you fill in the values of f of x? Go ahead and do that. It should be pretty quick. Let's just make sure everybody is on the same page here. Okay, we see, for example, when x is -2, f of -2, we replace x by -2, we get absolute value of -2 minus 2. It's absolute value of -4. Now, the most common thing I see half students do this, they just ignore the absolute value signs and write down -4. Okay? If you did that, you get a lot of company, okay? It's not what absolute value means, okay? It means definition, the absolute value of a number is equal to the number if the number is positive. If the number is negative, it's equal to the negative of the number, which would be positive, okay? That's a definition. That's a definition you want to keep in mind. In any case, if we do this now for these numbers, we'll just do f of -1. The absolute value -1 minus 2, which equals absolute value -3, which equals 3. So we're going to get 3 here. If x equals 0, we get 0 minus 2 is -2. The absolute value is 2. And we pretty quickly, first of all, see the pattern, but we want to confirm the pattern. Like, why is x equals 0? Or why is f of x equals 0 when x equals 2? Well, f of 2 is the absolute value of 2 minus 2, which is 0. So if we just went with the pattern, this would confirm the pattern. Now we really ought to write it out for every number. And down here, when x equals 4, f of 4 is the absolute value of 4 minus 2, which is the absolute value of 2, which is 2. Try to put absolute value of 0 equals 0 here. But there it is. Okay. Now let's ask a question. How far is but those things really carelessly. Okay, here I've got a number line and I've got x equals 2 marked right here. So if we're at 5, how far are we from the x equals 2 line? 3 units, right? You can count them. 1, 2, 3. Okay? Or you just do 5 minus 2 and you get 3. Okay? If we're at 0, how far are we from the x equals 2 line? 2 units. Well, my point is that f of x, this absolute value of x minus 2 function, is the how far are you from 2 function. Okay? Tells you how far x is from 2. Call it the distance from 2 function. Okay, it's kind of an important picture. Not sure how much open math stresses it. But if you want to understand it in a simple picture, then that's worth understanding. Okay. Now let's just do a little algebra with this thing. Let's say solve the equality absolute value of x minus 2 equals 10 times 0. Okay. I'm not actually going to ask you to do it. I'm going to do it for you. In the first place, you could answer this question by just telling me what numbers are 10 units from 2. Well, 12 is 10 units from 2, and so is -8. Okay, they're two numbers. So your solutions are going to be 12 and -8. Absolute value of 12 minus 2 is absolute value of 10, which is 10. Absolute value of -8 minus 2. -8 minus 2 is -10. Absolute value of -10 is 10. So pretty simple to do this. But the way you want to formalize it, because equations are not always this simple, is you want to say x minus 2 equals 10. Or x minus 2. Well, actually, I want to do -10. Okay, x minus 2 is -10, or x minus 2 equals 10. Now, in the preliminary work we did, we saw some of this. You solve the equation x minus 2 equals 10, equals -10. You get x equals -8. Solve this equation, you get x equals 12. Of course, you want to do the steps, just to be in the habit of doing the steps. Okay? Anytime you solve an absolute value equation, it's going to look like this. And you want it to look like this. It's going to be this, or it's going to be this. Okay? I stress this in my pre-calculus classes. I've got 20 people in a pre-calculus class, 18 of them will just leave the absolute value signs off and solve one equation, get one answer, because of failure to review or understand, or let AI do the work for them, not understand what is done. Okay? Various bad habits. So you have good habits. Everybody here has good habits. So make sure you stay with the good habits and write out things as you've been doing. So let's look at a couple more equations, okay? How about this one? Now there's a picture that can go with that. There's a little picture of the x-axis that can go with it, but that's a big jump. You don't want to try to make that jump. Just kind of imitate what you saw me do on the last problem and see what you get. Okay, well, I'm happy to say that everybody's on track here. Everybody started off by writing 4x plus 7 equals 12, or 4x plus 7. Well, actually, I usually put the negative on the left, so That's what people are doing. So again, 4x plus 7 equals negative 12, or 4x plus 7 equals 12. That's all you got to do to start an absolute value equation. And then the rest is hopefully easy. Now, it depends on what you have under the absolute value signs. The equations you get here could be a little harder to solve than these, but and people are doing this. They're taking the equation negative 7 equals negative 7, getting 4x plus 7 minus 7 equals negative 12 minus 7, so that 4x equals negative 19, so that 4x over 4 equals negative 19 over 4, so that x equals negative 19 over 4. And you can kind of check that. If x is negative 19 over 4, then 4x is going to be negative 19. And negative 19 plus 7 is negative 12, and that works. Now here, you're going to get x equals 5/4, I believe. No, yeah, 5/4. So your solution set is the set negative 19/4, 5/4. Now we want to graph that solution set on a number line. So I'm going to make a mark here for x equals negative 19/4, and a mark here for x equals 5/4. Then I'm going to pose a question. What number is exactly halfway between negative 19/4 and 5/4? How do you get the number halfway between two numbers? You add them and divide by 2. Okay, so let's say halfway between, I'm just going to mark it halfway between. I'll just mark halfway there. It's roughly halfway between. That's not too bad. Okay, halfway between negative 19/4 and 5/4 is what? It's negative 19/4 plus 5/4 divided by 2. Add them and divide by 2. Well, we're not going to take time to add these. I'm just going to show you, but make sure you understand. That's to add fractions with like denominators. You add the numerators and keep the denominator. So it's negative 19 plus 5 over 2, which equals negative 14 over 4 divided by 2. Which is 1/2 of negative 14 over 4, which is negative 7 over 8. No, sorry, it's negative 7 over 4. Had to be. There's a connection with this equation. I'll do it just kind of quickly. We're not going to spend a lot of time on it, but something that's worth seeing. Okay. Four x plus 7 is the same as 4 times the quantity x plus 7/4. It's just reverse distributive law. By the distributive law, 4 times x gives you a 4x, and 4 times 7/4 is 7. That 4 could go out in front of the absolute value sign. Equation. You could divide both sides by 4. And you get absolute value of x plus 7/4 equals 3. Okay. Well, there's x equals negative 7/4. How far is it from negative 7/4 to 5/4? Well, you subtract negative 7/4 from 5/4, you get 12/4, which is 3. So another way to solve this would be to factor out whatever's in front of x. So you get x plus something. You see where your center point is. And that can be a useful thing to do. I probably won't test you on that, but it's worth thinking about. Oh, boy. Say it all. But you can move on. Okay, I didn't have the camera on. Dealing with inequalities, absolute value of x minus 6 less than or equal to 14. Let me write this out in the what should be, well, what this means that x minus 6 is less than or equal to 14, as well as x minus 6 is greater than or equal to negative 14. Whereas absolute value of x minus 6 greater than 14 translates to x minus 6 is greater than 14, or x minus 6 is less than negative 14. Now, we worked this out, didn't have the camera on, so we'll have to go through it. Now, the first thing I want you to see is we have an and here, we have an or here, and see which way the inequality goes. You simply need to know that. Now, there's a lot of sense to it, and if you do the solution, the sense comes out pretty easily. You solve x minus 6 less than or equal to 14, you get x less than or equal to 20. Solve x minus 6 greater than or equal to negative 14, you get x greater than or equal to negative 8. If you don't understand that, sit down, write out these inequalities, and solve them yourself. Okay? So x has to be less than or equal to 20. Well, here's where x equals 20. X is less than 20, everywhere to the left of 20. Also, x is greater than or equal to negative 8. It has to be both. In order for x to be in the solution set, it has to be both this and this. So it has to be greater than negative 8, greater or equal to negative 8, which is everything to the right of negative 8. So it has to be to the left of negative 20, has to be to the right of negative 8, meaning it has to be between negative 8 and 20. And that's an interval, the interval of negative 8 to 20, closed interval, and all that stuff. Let's see a little bit more about what this means. What's halfway between -8 and 20? Well, you can add -8 to 20, you get 12. Take half of that, you get 6. How far is it from 6 to 20? Well, units, isn't it? And from 6 to -8, that's 14 units. Distance is 14 units. Okay? So we can say that absolute value of x minus 6 is less or equal to 14 means that x is within 14 units of 6. Okay? The furthest you can go out here to be within 14 units of 6 is 20. The furthest you can go here to be within 14 units of 6 is -8. All right. Now, this one, well, you write out the inequality using the rule I just gave you and that you're going to see in open math. You have an or between these. X is greater than 20 or x is less than -8. Well, here's x equals 20, here's x equals 8. X minus 4 is greater than 16 if x is greater than 20. So x has to be greater than 20 or it has to be less than -8. It can't be both. It's got to be one or the other. Whereas in this case, x has to be both less than 20, greater than -8. So that the absolute value of x minus 6 greater than 14 means x is at least 14 units from 6. Looks like I wrote down 16 there since both they were recorded. Okay, important to understand all of that. It's not particularly difficult. You simply write things out according to the rules, one step at a time. Open Math will give you plenty of additional information if you need it. There's your basis.